mobility apps or services. Usually, yeah, you open your phone, you have to scan maybe the QR code of the scooter or whatever, and then you type your destination. You say, I want to go there, bam. And then it provides you a road first, and then it provides you, yeah, an evaluation of the duration of the trip. So it tells you, okay, since I know you are here in the city and you are going at that point, so your trip will last for that much minutes, and it gives you an approximate arriving hour. So this is the feature that we will develop together. And basically, yeah. So I think that even if you are not used to read code, you should join and not be afraid to jump in, because in a short time of 90 minutes, you will follow me, like processing the different steps of a common data analysis, and then you will be supported in a guided workshop to do it by yourself. Basically, all the code has been written by myself, so it's just a list of steps on which you will click and follow the result to understand better how is the software working in the box. But I mean, you will never have to write one single line of code. It's all written for yourself. What is interesting here is that you will access a vision of how these mobility apps work from the inside. All you need is a usual Google account. So there are no extra license. There is no other platform to use than the Google one. And so no fees are needed. Basically, it's all free tools that you can access simply by synchronizing it with your Google account. We will work, I haven't named it here, but we will use Google Colab. Google Colab is a tool that is attached to any Gmail account. And it basically helps you, I mean, it gives you all the developing environments you need to process some data analysis. And so what we will do together on this mobility data, you will be able to process it basically on any kind of data analysis of any kind of business area that you can find on the web. So when you will unlock this as a skill, I mean, being able to find and recognize a notebook like somewhere on the web, on GitHub, or even in usual blogs or whatever, Google research, you will identify in a notebook that you know is doing something that can be useful in your business. And then, you know, you will learn how to simply like run the notebook, like coders, data analysts, they have written the code for you. You just need to unlock it. And I'm insisting on that because I remember myself, I started to code basically last September. So I think I joined a bootcamp, a coding bootcamp 1 year ago, and I was a really newbie. I never wrote one single line of code. I tried to do that by following some MOOCs, but it was really, I mean, impossible for me to go into it. When you are not used to, it's kind of stupid, but when you want to click on your computer, you're afraid of doing something bad. And so, yeah, this is something that we will typically unlock together in this session of tomorrow. You will learn by looking at me doing it. You will see that it's kind of easy to do it, and you can do it by yourself on any kind of notebook that will be useful for you. So what's the next? Okay. Here it is. So I don't know, maybe Sudha, you want to add something at this point. Otherwise, I will start to help the students to set up the environment for tomorrow. Maybe some of
sorry, Julien. Can we just find out from the students who are here? There's no pressure. If anybody wants to, they're welcome. They don't want to, it's okay. But I would just want to know what's people's background, or, you know, do they know machine learning? my typical students are product and business leaders, and some of them might have come from a tech background but not doing coding anytime in the recent past. So I'm just curious to know the background of people so that we can make sure that we give the right kind of information and setup. I don't want us to jump in straight to a setup. Yeah.
If anyone wants to jump in, please do. You are very welcome. It's always the first that needs to make the effort of
yeah.
start.
So do people want to just introduce themselves? You don't need to say about your specific coding or anything. Why do you want to learn machine learning? What's your background? If you can just spend like 30 seconds. And if you don't want to, that's okay. If you don't want to speak up, you can say in the chat. That would help set context. Because I see at least one student who's done like a full LiveLab with me in the past. 2 students actually. And I'm just curious. Okay,
we have one message from Sanyukta. So yeah, basically, if you already used Collab, you'll see like there is no barrier at the entrance of this class.
Okay.
It's very easy. Yeah.
Okay. Anybody else has done anything with machine learning? Because I teach a course called No Code AI Data Science for business users, where they know machine learning, but they never go build it. And then there is one on No Code AI, which is, where I'll give them a No Code AI platform where they would feed the data. So the bulk of the course experience is to learn machine learning, deep learning, supervised, unsupervised, even fundamental models and everything in English, right? Without touching a piece of code. But then they are very comfortable with data. They'll do feature engineering and stuff with data. The hands-on piece is more with data, and then they'll feed this data into a platform. Familiar with ML, but not coding ML. Okay, thank you, Emmanuel. So that's good for context, right? So one of my personal experiences, I came from being an engineer and I kind of, don't code anymore, and I can get dangerous if I want to. But I find that whenever all of these things are explained, it's done by engineers for engineers, so it's super easy. So I usually go into many of these classes and I get stuck on something that's the very basic stuff. It's not really the complicated thing that the engineers are trying to solve for. It's something in the setup. So the big thing with coding versus non-coding for me is a mindset, right? So the good thing with the product or business person is they're very good at thinking about the big picture, starting from the customer into the product, right? And so they deal with ambiguities and they're okay with that, right? Whereas if you're a coder, you're thinking very logical in a single track. And so you expect to do A, B, and C, and then you expect it to fail. Like, I think the thing with coding and engineering in general is you build something and it fails. And you say, okay, let me go fix it. Let me say what went wrong, right? And it's not a bad thing, right? It's like, oh yeah, I left this one variable, or, oh, I needed to add this extra library, or you would kind of learn that after you do this enough number of times. Whereas when somebody who is not coding, when they come to do this and it gives an error, they think they did something wrong. So I want us to be aware of that, because artificial intelligence and computers, however we say they are intelligent, is only as intelligent as we make it. And AI is the not so smart intelligent thing out there.
Definitely. There is also something good to know, is that we think that coders usually they write lines of code like that and boom, it works. But no, it's not the case. Basically, you write a line and then you have to debug it, and the debug takes probably like 70 or 80% of your time. So we spend our days googling error stuff and trying to fix it. That's basically
Good thing is, I'm so thankful that Ananya chose to write her intro in LinkedIn, because I set up the live stream so that we can chat with people on LinkedIn also. I could not find that link because I set it up. It was not giving me the live stream link. So thank you so much, Ananya. I'm going to copy that over and bring your intro here. Okay, there are a couple more people introducing. So Ananya did do an intro. Do you want to look at that? Kari has an intro and Ananya has an intro.
Okay, very good, Gary, that you come from cognitive psychology background. It's so you know how a brain works, and so this is exactly how we are, developing machine learning tools.
Yeah. I think Kari is more smarter than us because she knows more about how the brain works. Yeah. Thank you, Kari.
Sure.
The future banking experience, yes.
Okay, and then there is Sam, who's our teacher, from Sam Wigglesworth from Oxford, who teaches the LiveLab NLP course. And then we've left Ananya. You might want to read out what Ananya is saying.
Okay, Ananya, it's good what you are looking for. So just saying for the other, you are product manager and you would like to start data science and machine learning to implement machine learning features in your fraud detection platform. This is very great. I think that you have a coding developer experience, so I think it will be really easy for you. Yeah, you will just have to learn how to use these different libraries which are specific to machine learning, and then it's all about thinking about how you can apply it to your business. You will see there are a lot of things on internet. If you start to Google machine learning and the name of your business area, you will think about a lot of stuff. Talking about
so Julien, I want to jump in with one thing. So yes. One of the things we are going to do is we are going to have your LiveLab machine learning class tomorrow. So people will get a sense of how sausage is made, right? How it works on the inside. Obviously, you're going to show more about data visualization and all that. And then on 28th is my no-code AI data science course. And I believe Ananya signed up for that. So there they will learn the foundation of machine learning or the whole data science. And also we will take another data set for our mobility data, which is from KiwiBot, a delivery bot, and go through the exercise of, okay, we want to find a business problem to solve. And how do you arrive at a problem statement to get the data set? Today, you've made it easy. You're giving us the data set as a starting point. That is what I find most courses outside, anywhere you want to go learn machine learning as an engineer, gives you a data set, which is clean. The computer understands it. And it is talking the language the AI wants to understand. And so that class will teach how you get to the data set and then feed it into a model. We can even feed it into a Collab now that we learn it from you. But my plan is to teach them using a platform like Akio or IBM Watson, which doesn't even need to look at Python. It's a little bit more.
That's a good point. I was curious about Emanuele's experience because Emanuele said that he's familiar with machine learning, but not coding machine learning. So can you, Emanuele, tell us more about what platform or how do you usually use machine learning with no code?
Emmanuel, if you want, you can speak up or you can chat. That's okay.
Yeah.
Yeah, 1 second. Yeah, so it was primarily like a course on machine learning, and it was an MIT course, and kind of understanding how different components, what kind of setting up the framework, understand the different classification, regression, all those deep learning, but we had to do some exercise, but we're pretty much was more on the basic concepts without necessarily doing any coding or any everything was kind of canned. It just, okay, if you have this, you do that, and that type of stuff.
So were you running some algorithm, or it was conceptual thinking?
More conceptual thinking, and then looking at references and say, okay, this is an example, you can run that, but it was already pre-made.
Okay, got it. So I think that, for example, for yourself, you will have a good understanding about the whole picture, and now you will be able after the class to basically run different machine learning algorithms. So they are usually two classes of machine learning algorithm. We are dividing. I mean, there is the regression family and the classification family, and so basically both provide predictions on data. Depending the nature of the data you want to predict, you will use rather like regression algorithm or classification algorithm. Basically, numerical data, continuous numerical data, such as, I don't know, a size or the weight of something or someone. So these are continuous numerical data, right? And so for this kind of data, we are using regression algorithm, which helps you to predict the size of something that weighs that quantity. And when you are trying to predict a category or a class of an object, for example, is it red, blue, or green? So then we are using classification algorithm or ranking algorithm. Sometimes we call it ranking algorithm. But it's basically always the same. It's always the same steps and process. So you start to import your coding environment, then you are importing your data. You do some exploratory data analysis. It's kind of superficial, but it helps you with some stats to visualize the composition of your data set. Then usually you are doing a sort of correlation analysis. So you are checking which data is depending on which one. And after that, when you have found like which data are depending on each other, you usually you start to think about how you can solve your problem or what kind of problem you want to solve. And to do that, you assign one data that you want to predict depending on the other features of your data set. And then, yeah, you start to run the machine learning algorithm. It usually provides predictions that are more or less good. And then you loop by, I don't know, cutting the outliers, or you loop by selecting some more specific features of your data set, and you run the machine learning again. And so, and then you check the accuracy, and usually it's better. Sometimes it works, so you know that you have to get back. But otherwise, yeah, you are looping with your machine learning algorithm. You are looping like in the data sets until you have a satisfying prediction rate. And so usually when you end up, I mean, close to 5% of errors, you know that your model is almost ready for production. So you can assign an automated task, an automated analysis task to your algorithm, and you know that he will have 95% of telling right. So it's acceptable for production. I am thinking, for example, about the case of Ananya in the Kari in the financial sector. Specifically now with the cryptocurrency, but it's kind of the same. It's always the same. It's always the same background analysis. So a common predictive model consists in predicting if some value will go up or down. So traders need this kind of automated decision support. And so basically, yeah, a very common use of machine learning in the finance or in the banking background is to assist people in deciding if they need to buy or if they need to sell some value, yeah, some product. Yeah, so predictions, machine learning are doing that. they can send you an alert when it's the best moment to sell or the best moment to buy, and you can visualize on graphs the predictions of the evolution of the rates of this or that product or value. In the fraud detection platform, as Ananya told about, well, I've been working a bit on fake news detection. I don't know how close you are to that, but yeah, for example, in the fraud detection, usually what you do is that, I mean, you are assuming that a single user or a single ID can make an error or a fraud by time to time. I mean, it's human. But then if the same ID is always trying to trick your system or always providing fake news, yeah, you will put him on a red list, right? And then you will try to check if there is a bad computer behind, or if it's a human that are a bad mindset or whatever, and then you will try to fix it directly. And if you cannot fix him because he's not changing the behavior, so you will delete the access of that ID to your platform. So this is also done with machine learning. So that we have some more messages. Alexander. Azure machine learning. So no, I'm not used to any kind of platform. And basically, I learned how to do machine learning by coding myself. And so, yeah, I like to do that. Honestly, it's such a pain on the beginning. I will be honest with you. But then when you know how to do it, first you're happy, and then you know from the very micro level you can I mean, do exactly what you want. So I chose to take that time to learn how to make this. Yeah, so I don't know the platforms like Azure. Yeah. So then for the second question, which is the best Python framework? I will say that there are no best Python framework. It depends about what you want to do. Some of them are more complete package. So this is something. I know, for example, I'm using a lot scikit-learn because it provides a lot of good algorithm. But then, I mean, scikit-learn can do some stuff that PyTorch and TensorFlow cannot do. So it depends about what you want to do. You will need some different features available, and so yeah, you will choose a different framework. What's interesting is that usually when you know how to use one, you know how to use the others, because it's all written in Python, so it all works the same. Yeah. In the class of tomorrow, we will use scikit-learn. All right. So I don't know if you have some more questions. Otherwise, we will maybe start processing the setup.
Yeah. And can we just introduce Priyanka? Priyanka, do you want to introduce yourself? She's our new teaching assistant, so she'll be around today. If you want to do this, follow along. Maybe you can go into a breakout room and she can help you if somebody is specifically stuck. Otherwise, she'll be around tomorrow. Priyanka, do you just want to give us your background and introduce yourself?
Yes, yeah, hi everybody. This is Priyanka from India, and I am basically a data analyst, working as a data analyst in a private company in India. So I have done my post-graduation in data science, so I would be very happy to help you.
Okay, thank you.
Yeah.
So let's jump on the last one, but I also want to give you, so I will give you the link. You will go on my GitHub and you will find, so you will find the information that
You want to add that to the chat, if you don't mind?
Yes, I will add it in the chat.
It'll be easy for people.
So you will find the same information, basically, that the one which is on the slide. Where is the chat? Here it is. So Ananya, no, for the class of tomorrow, I'm using the same, I'm using one machine learning algorithm, but we will use different libraries. So I chose to spend more time on the whole process than spending too much time on a machine learning algorithm. So you will see one, and basically, well, if we have time, we can compare the results of 3, 4, but it's exactly the same. I mean, you just have to change one word in the code. I can do it for you. Yeah, it's just you are calling one algorithm or 2 or 3, and then you run it with the same pipeline.
So the no-code AI platforms that we use end up doing this multiple algorithms in their brain, and then we'll give a recommendation. So the IBM Watson, if we use, it will actually say, I use these 5 algorithms. It will show us if there are 5 paths with different levels of accuracy. It won't show more than that, right? It's just saying in visually that it is done 4. So technically we could do that if that's what we want to do after we get the foundation here.
Yes, exactly. The funny thing about tomorrow, I mean, I really like it. It was really cool for me to work on that data set. I've been able to use different visualization on maps. You can see we will quite easily process very cool visualization on maps, clusters, heat maps. You will be able to visualize how busy is the city at this or that moment of the day. So which streets are the most used by these transportation systems? So yeah, that will be a lot of fun, I guess, if you like it. So now you are on the GitHub link, right? We'll start with the first step. So you will go you will click on this link. It's the open data repository of Louisville. Here we are on the dockless vehicles data. So you see the 4 brands, which I haven't said the name, just to keep like not promoting any of it. But these are the 4 vehicles providers across Louisville City. And I will ask you to download. So here we have an information first, data nodes. We have some detail about each data column. So basically, in the data set, you will find a trip ID. So it's Louisville, which has they are creating anonymous. I mean, they have been creating a trip for not being able to identify who is the user. So of course, these data sets respect the privacy of Louisville. You have a trip ID, a start date, a start time, end date, end time, trip duration, trip distance, and then you have latitude and longitude for both start and end, and a day of the week, and the hour of the day. This is what the dataset contains. If you go down, you can have a sort of pre-visualization of the data. Here you can play with that if you want, but we will make it by ourselves tomorrow. And so now we are on the list of the data sets. I will ask you to download the second one, which is called Dockless Vehicle Trips Block Level 2018 August to 2020 January. So click on the download button of the second line. It will download the CSV file that you can basically open on your computer with Excel, even, I am myself using numbers sometimes, or I prefer Google Sheets, to be honest. But so, you can already, well, you should be able to visualize it, but no, I forgot to tell you, that's one of the reasons why we are using coding environment, is that you will have more than 500,000 lines of records in this CSV file. which is absolutely not supported by numbers, Excel. They all stop between 50,000 and 60,000. So when you have a 500,000 file, it's impossible to read it differently than using the coding environment that we will use tomorrow. So yes, please download the second file, and then for your exercise, I will ask you to work on this other file that is more teeny, but so you will play with that by yourself. We will assist you. It's called Dockless Trip. 1st February of 2020 and 8th July of 2020. Trip details from February. Okay. So yeah, download this second file. It will be for you then to apply it in the workshop. We need 2 files. The second one here in the list, and then you go down, and it's the last CSV one. CSV, okay? It's a brown icon. Okay, right. I assume you all did that. And now we will.
You want people to do that now? You want people to go and download those 2 files? That's the first step, right?
Yeah, well, if you feel that you can do it by yourself later tonight, honestly, I'm good with that. Okay, it's just you will have to do that to join the class tomorrow, because we will start. So tomorrow there will be no introduction like that talking. It will be straightforward. You have 90 minutes, and I want you to take the whole. So yeah, it will be. We will start with the coding and the environment settled. I mean, set it up. Sorry for my English.
Yeah.
But yeah, I mean the setup now.
And just so you know, if you know, right now we're just going to download 2 files, nothing else, and then we're going to do some Google Colab setup. And if somebody has trouble doing that, you can talk to Priyanka, DM her right here. Yash has also volunteered to help out if you need. They are both here, so you can DM them. Otherwise, we will still be available. That's one thing, right? That's the beauty of doing this, is not just get a GitHub notebook and just go run with it, right? Julien is going to be available. You can talk to Julien or me. If I'm able to do this, guys, so I can tell you, you should be able to do it. So you can get help if you need. Don't feel, if you're stuck.
Sure. So that was the first point. Downloading the data set from the Open Data repository. Then we go on the second point, which consists in creating your Google Colab account. And so for that, you will click on the second link. I will try to show you in a private incognito window, but yeah, I mean, for me, it's already. For me, I already created my account, so you will not see the same. But please go on this second link. Incognito window. Okay. Yes, you will. So stop share 1 second. Everything here. I think you can see my desktop now. Yes, and so when you go on this second link, you will see that, which is welcome to Google Collaboratory, and don't pay attention to these things. I don't know what they say. I never read it. All you need to do is sign in. So you click on sign in, like all Google apps, okay? And then they will ask you to fill your Google information. You fill the email. You fill the password, and then you click on next. Now create account first, and it will create you a Google Colab account.
So you don't need to create a new account. You're going to log in using your Gmail. So
Yes,
I'm assuming most everybody here has a Gmail, so you don't need to. So the create account is for people who don't even have any kind of Google account.
Thank you.
Right, so
yes.
you're just going to log in using your Google account, your Gmail account.
Exactly. And so then when you will have create one, you will arrive on something like that. and it asks you to upload. So the upload window appears by default. If it doesn't, imagine you are here.
Sorry, Julien, can you just pause and check if people are able to create the.
So yeah, that would be great to have the feedback on someone. If someone is actually following the steps, please tell us that you are doing it at the same time of the presentation, so we can check if it's hard for you to do it, or if you can process the steps easily.
So that pop-up that you saw, I didn't see it. For me, I was able to log in using my Gmail.
Yeah.
And then it just did all this, whatever is on the screen.
Yeah.
And I got distracted trying to do those things. the getting started, the part. Yeah. But the pop-up that you got, I didn't get that.
Okay, no worries. And so you have this window, right? When you go on the link?
Yeah.
Okay. So then what you have to do is
everybody comfortable? Are you guys able to just go to the collab.research.google.com and just log in with your Google account and then get to this screen, and then you're done. You have a Google Colab account. Are you guys able to do that? Can somebody say yes or no, or going to do it later? Out in the chat, please. Especially when we do this on Zoom, it's very hard whether we're talking to ourselves. I know there's a lot of you here. So yes, thank you, Ananya.
Okay, cool.
Okay. Is there anybody else who's not doing it now, or, doesn't feel like it seems straightforward? Because I know people who don't do Python, who don't like to see Python on a screen. Yeah. So for all practical purposes, you can ignore it for now. You can just go log in to collab.research.google.com with your Gmail account, and you're done.
Okay, I will assume everyone is following since we have no stop messages. And so when you are on this Collab desktop and you are linked in with your Google account, you will click on File, the File tab, and then you will choose Upload Notebook. And here you find now Suda, the window that appears on my computer first. There are 3 different ways to do that. I mean, you can upload it from the Google Drive, but so far you don't have it on your Google Drive. They will propose you to connect it, to upload the notebook from the GitHub. This is what we will do. If you prefer to work from your local computer, all what you have to do is to download the file contained in the GitHub.
Why would we do that? Because for the purpose of this class, we're just going to use Google Colab, so we don't need to download it, right?
You don't need to download. Usually I prefer to download, just because, yeah, I don't know. There is no reason.
No, because you know a lot more, so you're going to do more programming by downloading it on the.
I guess so. Yeah, I like to save what I'm doing on my computer. Well, I think there is no very rational reason, to be honest.
Okay. So for the purpose of this class, people don't need to download. They can just straight away go to.
No, yeah, as you like. You can upload it by GitHub. But you also, if you downloaded the GitHub file on your computer because you prefer it like that, you can upload it from a local computer here, or you can upload it from your Google Drive if you did transfer of the file on your Google Drive. But there are no specific reasons to that. It's not changing nothing.
Okay.
Yash, you are asking something. You raised your hand.
I just wanted to help a bit here. So basically, everybody has downloaded it from GitHub. So in the previous step, they have gone to GitHub and they have downloaded it. So now they have it on their local drive.
Yes.
So what I was thinking was, we will, for today's class, if we can just show the upload, because too many options will be confusing. So if as it's already downloaded on the drive, if we can upload from the local drive. Then-
Yash, I didn't download the notebook to the drive. I just followed along literally and I downloaded the 2 data set to my drive. I don't have the notebook. So there are 2 things, right? Julien asked us to download two of the Louisville data that we have downloaded. It is sitting on our local computer.
Yeah.
Cool,
That's it.
cool. I got it.
I don't have the notebook downloaded.
Okay, got it then. Thank
So
you.
But yeah, that's a good point. If people have downloaded it, once they figure out, then that gives them more flexibility to go do that. So in future, there could be other files like this that somebody is building a different model and they say, hey, I have this notebook, and then they share. That's what data scientists do with each other, right? They build a notebook with Python and then they say, hey, I have this notebook that is solving for this problem.
Yeah,
So,
usually.
yeah.
So yeah, I can show you both, but now we will start with the GitHub upload. So when you have this upload window open on your collaboratory, you will copy paste the link of the GitHub repo. Okay, so you go in the chat. And then you copy paste the github.com/democracystudio/LiveLab September 2021. You copy it, the URL, you paste it in the here in the space for that on the upload window. And it gives you directly, like he's recognizing, right? He's recognizing the repository and he's recognizing which file he can open into it. And so basically, that's what appear on my screen. I have a direct link to the notebook, and so I can click on Open Notebook in a new tab.
Sorry, Julien, can you show that again?
Yeah.
So if we have to get it from GitHub, what's the URL? Can you put that URL on the chat?
Yes, here.
Thank you.
So you copy paste the URL of the chat here. You can basically, if you open the tab, I mean before that, I think if you are on your Google and you are, I mean, on your Chrome or whatever web browser, and so you can directly copy paste the GitHub link from here, right? So you copy paste the GitHub link.
Okay, did it.
You have it?
Yes.
Copied. Yes. And so then here, when you go on the upload window, it's written enter a GitHub URL, right? So then you paste the URL here. And it's directly recognizing what's in the URL. Are you following, Sudha?
Thank you. Got it.
Yes, thank you, Priyanka. This is the URL. And so when you have that, you click on the square with the target, with an arrow. Open notebook in a new tab. Here it is. And so you all set. I mean, now you have the data analysis file with all the code. That is not important if you don't understand what's written, because the Collab will process it for you. All what you have to do is that, yeah, upload it here, and we will start tomorrow from here, right? So step by step, you will do the steps that we've been talking about, like clean data sets, exploratory data analysis. You will look for dependencies between variables, make some data visualization, and then finally we will make some machine learning on mobility data.
So those are the steps we'll follow tomorrow.
Yeah.
So we don't, yeah.
Exactly. This is the code.
Okay, so that's it. We're done with the setup.
Yeah, let me check if there is one more step. I think there is one. Yeah, the only thing to do is to upload the files in your Google Drive. So basically, if I go on my drive,
The two files, the two data files that we got from
Yes.
Louisville.
The data sets from Louisville that you downloaded, you will transfer them into the first, I mean, in the root file of the drive, right? This is optional, but it will make it more easy tomorrow for you to run to upload the data. So take those two files, Louisville and Docker strip, and you slide it and you drop it in your Google Drive. And then you can see it here. I have it there. Docker strip, open that again, and Louisville Docker strips. Yes, Yash?
So just a thought in case you're wondering how much of access of Google Drive will be there just for the students. So the Collab notebook will access only the file that we specify. It won't have access to any other files in the Google Drive, and it is very safe to upload it to Google Drive and connect it to Collab. There is nothing to worry about that if you're doing it for the first time.
Oh, that's a good point.
Thank you,
Yeah.
Yash.
So it's not snooping around your Google Drive. Yes, thank you. I have a question. Why does it have to be on Google Drive? Why can't we just download the file and just access it directly?
So yeah, Google Colab is linked to Google Drive. It's the whole Google environment. Usually, as I told you, I'm doing it from my local computer, and so yeah, I'm hosting the files in local. But then the thing is, I wanted to make the most simple as possible for you, and basically we all have the same pass. Pass to our Google Drive. It's the first cell that we will see here. So we all have the same pass here to upload your data set from the Google Drive. And if everyone is hosting the file in local, we all have a different pathway. So it will be hard. It will be hard just because everyone will need some different code here. I mean, a different line. So I wanted to make it the most easy. So then you don't have to type one single letter of code. You just have to run it. Okay,
I have a question related to that. I have been through such classes where they'll give you a notebook instead of a Collab notebook. It's been a Jupyter notebook, yes, which has all. But what they will end up doing is they will say, go to this one line and change this one thing, change this variable, get this code and insert it here. Yeah. And it's not hard, but for a person who is not comfortable with Python on their screen, it is intimidating. Yes. So you're not going to make us touch this code at all. That's your promise?
That's a promise. Yeah, I've been trying it 3 times. Yeah, there is nothing needed like as typing anything. Yeah. So
we are just going to look at this code and run it.
Yeah, you will just have to click. You will just have to click. I don't want to tell too much because I don't want the students like to be tempted of doing the class before the class, you know?
That's right.
But basically, yeah, you just have, now if you have this setup done, you just have to click on run and it's running. I mean, yeah. But so, as you said very wisely, Sudha, I think the biggest outset, I mean, the main thing that the class is bringing is that you will have all the comments detailed. What are you doing in each step and how is it like going through the best machine learning deployment? So yeah, all the comments are useful. Yeah, obviously. Okay. That's probably the most.
So we've created our Google Colab. We downloaded 2 data sets, and then we've uploaded the 2 data sets onto Google, our own Google Drive.
Yes.
That's the setup. And we are done. We can go home.
Yeah. I'm staying home.
Okay, tell us what to expect tomorrow. I saw you read through this. What does this mean? What does this mean? Like, so we did the setup of the environment.
Yeah.
What is cleaning of data and exploratory data analysis? And I come from an analytics background, so this exploratory data analysis cannot be a one sentence here. So it was my whole job. So tell us a little bit more, especially we have a bunch of people who come from very strong analytics background. And then there are people who don't touch data, right? So cleaning the data seems scary to me. So can you tell us what to expect or show us an output?
Yeah, there is no reason to be afraid. I can maybe check. Do you remember the thing that the presentation I did to your school?
Oh, you did weekly Wednesday, yeah.
Yeah. So I think I can share you. It's always the same. Sorry, it's always the same steps. So basically, when you do data cleaning, when you get a new data set, you usually need to make it, I mean, it always contains a few errors, like it's like that. I mean, when you record, I don't know, that much quantity of data, there is always like 1 0 that is wrongly placed, or one letter that is in uppercase and it should be a lowercase, or whatever. So we always have to do some data cleaning. It's always the first step for having the best, I mean, the best results, like getting rid of outliers and all this kind of things. So basically, we start with data cleaning, which is deleting null values, trying to frame the outliers, and doing some things with the data types. So usually you don't work the same with numerical values and with object values. This is something that we will not do tomorrow. Tomorrow we will start by deleting news and making it more easy for us to call the first line by asking all headers to be, I mean, all letters in the code will be lowercase. There are no uppercase, so there are no errors of typing that can be done during the time where you code. So that's basically the cleaning steps that we will do.
So we are not going to actually do the physical cleaning. So your Python code is going to do it for us, right?
Yeah, no, you will not do nothing. When I'm saying that it's all handy class, is that you will not have to do nothing. Everything is done and it's working. I did it, Friday. So, I mean, I ended it Friday. It took me some days to do all that. But yeah, you have nothing to do. Everything is done for you. But still, I mean, you will be on the side of a coder. It means like the code is written, but you will be just like me or other kind of programmers behind your computer and process the code step by step. This is something that will teach you what's the process behind machine learning. When you are using an app, usually you don't see all that steps, right? You just click on it. So then now you will have a way deeper understanding on what's happening in the background of machine learning algorithm by processing it step by step with comments. Yeah.
So is this like when a data scientist builds machine learning models, are they doing this data cleaning using Python, or is that expected to be given to them by somebody else in the? No.
The data cleaning is we do. As for myself, but most data analysts do the same. We do everything with Python. So these are some specific functions and lines of code that you are using to clean the data. For example, drop one column or drop the rows where this value is equal 0. So all these things are done with the pandas library. Usually, pandas is a library from Python.
Yeah.
And so you do everything with Python libraries. The thing is, for example, when you start, the municipality or open data providers usually have to provide clean data sets. But I mean, it's usual that there are some errors into it, and sometimes they are not errors. They are just publishing the raw data from the machine. And then depending what you want to do as an analyst or as a startup, you will not want exactly the same kind of data. For example, maybe a guy that wants to fix the app, the mobility app, he will, for example, look only the trips that are of very short distance for whatever reason. And so he will have to drop all the trips that are more than 1 mile, right? For myself, it has been different. I don't want to study trips of 0 mile because basically it do not make sense. So one of the first steps that we will do will be to delete all the trips that are at zero mile of distance, because I consider them as outliers because they do not teach nothing for our model. So yeah, they are publishing raw data, and you always want to clean it based on what's your personal intention with these data.
So that is very, very helpful. So for the purpose of this class, we are just going to run through your code the way you tell us step run, right? We're not touching the data for cleaning. No. But since we have people who are business people and product people, what this cleaning actually means something for your business, for your context. So this 0 miles means the delivery bot or the bike was not moving. So it's useless. So that's very good example that you gave that gives us context. So I'm just saying for the purpose of people who are here, think about this from your lens. What does this data mean to you, right? Because we're using this data as an example, and then subsequent class, we will use a different data set, right? We will do something different, but the steps you're telling us will be the cleaning and this analysis and ranking and arriving at the inference will be the same. And the same Python code will do that for us, right? Okay. That cleaning part is clean. I don't need to touch data. I like it.
Yeah. I can keep going on that slide.
Hey, Julien.
Yeah.
Should we stop and ask people? Yes.
Yes.
I have copied those files, but this notebook is not able to find it. I mean, is there like a basic thing that I'm missing? Should I share my screen? Do you have time for that?
Share your screen is great. I will stop sharing mine. I think you can go for it.
Oh, maybe I don't have permission. But what it says is...
Okay, I can give you permission to share screen. Oh, yeah.
Oh, okay.
And if this, yeah, where are you? Sorry. Yes. And for the purpose of the pre-class, if people want to stay on, they can stay on, because we said 1 hour, we've gone longer. We always do that. We stay back till the last person is happy. So you're welcome to drop off and you'll get the recording, guys. You don't feel like you have to stay back, but.
Nice dark team. I like it.
Oh, yeah. So I have this file, open data _10. It's under my drive. Should be.
Yes, it's in your drive.
But yeah, so, but then it's not really picking it up. So I don't know
of course. The thing is you haven't, so you clicked on the second cell, but you haven't processed the first one.
Oh,
so
okay. Okay.
But if you don't mind, this is something that we will do tomorrow, because that's
See,
what
okay.
it's about.
This is exactly what Julien was saying. Now that we gave you a GitHub file, doesn't mean you just run with it and you have your model, because the exercise is not to just build the model, but to understand the steps. But
Yeah,
thank you for doing that. I was so tempted to do that, and I was trying to behave and listen.
Oh, but
So thank you.
It
Thank
will ask for a lot of
Oh,
comments
yeah.
from each step. So basically, yeah, it will take way too long if we start doing it now.
Yeah.
Yeah,
Okay.
yeah, sure. Okay, yeah, I remember
Awesome.
now. Yeah, it doesn't run all the previous steps. Yeah. Okay,
Okay, thank you, Ananya. So do you want to say what the other things? You don't need to go through all the details of that just now, but giving a context of the cleaning will be done by Python, that we don't need to touch code was actually better for me to hear.
But
So
everything will be done by Python. We start with cleaning, then we do some statistical analysis. EDA goes for exploratory data analysis. So it's the very basic of looking at one cell. So for example, on the other day, so this is typical EDA tasks.
Okay, you're not scared sharing anything.
Sorry?
You're
oh,
not
yeah, sorry. I was on, yeah. Forgot that. Okay, share. So yeah, EDA, second step, statistical analysis. So it's typically a kind of EDA output that you are checking at some statistics on your data. It helps you to visualize easily some things. So for the other day, we were working on citizen engagement. It's a bit different with 3 cities. So then, for example, with a quick look, we can make the difference between Taipei, Tallinn, and Tel Aviv in the engagement feeling variable. So it will look like that, having some statistics, means, and simple visualizations. Then the other step usually is here doing some correlation or regression analysis. So at that moment you are testing the dependency between variables by plotting this kind of heat map of the correlation matrix. You have all the variables, and you can test the level of dependency one on each other. So if we take, for example, this one, we can see that, yeah, the third variable, numeric frequency, is very close to the second one, numeric wish. I won't comment everything because, yeah, it makes sense. It's another case study, but still, we can see from the correlation matrix that they have 72% of relationship one with each other. So we assume they are depending one on each other. And then when it's a dark color, like here, minus 74%, it means like there is a relationship, but it's negated. Right? So it means the more the one variable is going up, the more the second variable is going down. And when you have this kind of numbers, such as this one, like the purple one, source TV, here the second case after source TV, 0.01. So you are very close to 0, and so there is no relationship between the TV and the wish to engage more in citizen engagement. So this is how you can visualize the relationship between your variables.
So we'll do that tomorrow with the Louisville data set.
Of course.
Yeah. Okay.
All what I'm showing now on this case study of last month, we are doing it tomorrow in the lab.
Okay.
And
so
then
we do the data cleaning and then the visualization to find correlations.
Yeah.
And all that is Python, right? Python click for every one of them.
Yeah, all is written in Python. You will see it's more and more complex when you go in the notebook, but you don't have to. You will just visualize how you can process complex things without knowing it, which is always good. So yeah, and then usually we do some kind of linear regression. So it's a way to visualize the dependency between two variables. So typically here we have some data points that goes between opinion share and engagement feeling. So, and yeah, we are doing this regression, which is the basic of machine learning regression algorithm, by the way. So, yep, and then that was machine learning to rank. So this one, it will be a bit different because we are doing regression analysis. But yes, basically that's it. We will compare. So I don't want to show you things that are not what we are doing tomorrow because it will just lose you. I mean, it's not useful, you see. That's it, basically.
Does anybody have any other questions? This is very clean, at least, it looked before you started off when I just looked at the screen, it doesn't have context. So it looked like you were expecting us to do a little bit more, but this looks clean to me. If anybody has any questions, we can take that and then maybe we can wrap up. And I see most people here except one person who's new, right? So if you have not signed up for the class, I just added the link and we have this special price, $199 going on till tonight. And you can go check the syllabus and what it covers and everything, and you'll get recording. So the plan tomorrow, Julien, correct me if I'm wrong, is you'll walk us through with this setup, right? So if anybody signs up now, obviously they can talk to me or Priyanka or you. And let me put my email also in here.
All those who attend tomorrow class, be sure that you will have done the setup before the class, because we don't want to use the time of the class to make the setup, right?
Yeah.
You want to jump in the machine learning like as soon as possible.
And then if somebody has, even while you're walking us through, so one thing is, if as soon as anybody signs up new, I will make sure that they've done the setup or help them with it, yes. Right? So I will follow up. And I've also given my email in case anybody's here thinking about this or want help or want to chat. During the class, like Ananya showed us a screen and tried to jump ahead 2 steps. If somebody does that, you're not going to share the screen with the world, right? We're going to send them to a breakout room, and Priyanka can help. So you can DM Priyanka and say, hey, I'm not following along and I've lost at some stage. Priyanka will look at their screen in the breakout room without changing the flow of the class. So you can go through that tomorrow.
Basically, what we will do tomorrow is that I will first run the whole data set and comment it step by step to tell you, okay, in this step we are doing this, now we are doing that. You will have visualization of what the code is doing, and you will visualize what you usually see appearing on the no-code platforms. It will appear in your notebook step by step. And then we will assist you. It will be a 50-50 time, I guess. Then you will be asked to run the notebook again with the other data set. So then you will do it by yourself. And at that moment, we will be able to help you and to provide you the support, individual support, for you to be able to do it by yourself. And yeah.
Okay. And at that point, if they run into any trouble, they can ask Priyanka, or if they choose not to do that live, they can do that later. They can get office hour with you.
Okay, of course, right? Of course, because the thing is, I don't want some students to spend time in a room trying to fix a basic thing, because he will lose the whole demo. I would like the students to first follow the whole process, so that we really understand the whole thing, get the whole content of the class, and then you will be able to do it by yourself, and you will assist you like doing it individually. But I think you will get the most of the class if you follow the first demo that I will do myself. There will be no error, and you will understand. You will have the whole picture. Okay.
Okay. And the students will have access to the recording. So even this one, and everybody who signed up today, I'm going to send them the recording. But tomorrow, when you do the demo in one go, they will have that, so they can watch it and follow along and do it on their own. And then if they need help, they can obviously, set up office hours or follow up and ask for help. Yeah. And so you'll be available at least till the end of the month on office hour, and right. So and the students will have access to the recording at least for a year, not at least for a year. So they can go back and put new data sets and try this again and again, or take something from work, or take this from the other class when we are going to do the no-code data science one, which I'm teaching with a pure no-code AI platform where they won't see the sausage making. They can bring that data set and try and feed this and see if anything breaks. I'm trying to try that. I like to break things. And so that's how I learn. So I'm hoping that would help. So this is clean. Unless anybody has any questions, we should wrap up. Guys, girls, do you have any questions? Comments? Did you find this useful? And please give us feedback. We have no ego. Absolutely. We want to help you. We want you to succeed. We want you to learn. And I can tell you on record, I've been through this intimidation exercise and I don't feel as intimidated as I make it sound, but it still can get to that place when I look at something new. So help us help you, and talk to us and tell us, if we can do anything better, And thank you, Yash, for, your suggestions and jumping in and offering to help. We appreciate that. You're a strong data scientist, but you want to come and help us with, basic Python. We appreciate that. So with that, maybe we should wrap up. I'm not hearing anybody say anything. And even if you find this useful, you give us feedback. If you think we should slow down, we should, stick to one flow, whatever, just what will work for you is what we want to make it work, because we want you to be successful. So please help us. Yeah. Yeah. Okay. So with that, I'm going to wrap up. Is that fine? We can close out. Yes, everybody.
Thank you, Sudha.
Okay, thanks. I'm going to stop the recording. Okay, thanks, Dan. I'm going to stop the recording. I have a recording.